In manufacturing, risk is often invisible at first. A tiny pore, a drifting dimension, a weak coating edge, a process that looks stable until it is not. For DCTC 2026, Sunrise Metal is upgrading the system behind every part. For medical precision, Clara makes the process more controlled. For harsh marine environments, Aqua builds reliability from inside to outside. For robotics, Robo reduces weight, improves precision, and strengthens fatigue resistance. For commercial vehicles, CommercialDrive connects capacity with long-term production control. More data, more visibility, more controlled capacity. From casting and machining to coating, inspection, and full batch traceability. And before the first mold is built, CASTA brings engineering decisions earlier. This is DCTC 2026, the next generation manufacturing system from Sunrise Metal. Now, please welcome Gilbert Chen, CEO of Sunrise Metal.
Hey everyone, welcome to Sunrise Metal DCTC 2026. Every year at DCTC, we do not only show new parts, we show what has changed inside our manufacturing system. In 2026, the question is direct. How do we make every process stronger, smarter, and more repeatable? Speed still matters, cost still matters, but for our customers, the real challenge is consistency. Today, we will show 4 areas of upgrades: processes, data, equipment, and capacity, inspection, feedback, and early-stage design support. In 2026, Sunrise is also upgrading production capability. We added a new 1,600 tons die casting machine for larger and more complex aluminum components. We introduced a new 500 tons UBE die casting machine for more stable precision castings. We added 2 new brother CNC machine centers to improve machining capacity and delivery flexibility. And we continue to use CMM inspection to support high precision measurement and process feedback. Today, we will look at Sunrise-Clara for medical and precision equipment, Sunrise-Aqua for marine and harsher environment, Sunrise-Robo for advanced robotics, and Sunrise-CommercialDrive for commercial vehicle applications. And at the end, one more thing, CASTA, our digital platform for die casting design. Let's begin. In medical equipment, a metal part may look simple, but behind that part, there's a serious question. Can it stay reliable for long term? In medical imaging, air system, diagnostic equipment, and precision instrument, small defects can create big risks. A tiny air pocket can become a leakage path, and a small machining area can become an assembly problem. A surface failure can affect cleaning, appearance, and long-term use. This is why Sunrise-Clara exists. Sunrise-Clara is our processes package for medical and precision components. It connects casting, machining, and surface treatment, inspection, and traceability into one controlled loop. For 2026, Clara is not only about making medical parts cleaner and more precise. It is about making the full process more controlled and more visible. The first upgrade is Sunrise Vacuum Cast 2026, vacuum die casting technology. In the past, many factories only care about the final vacuum value, But a final number is not enough. The process matters. For Vacuum Cast 2026, every mode has a standard vacuum curve. Every shot records vacuum level, vacuum time, and vacuum curve status. If the vacuum is not reached, production should not continue as normal. If abnormal vacuum behavior appears continuously, the process must stop for inspections. Every abnormal shot is marked and separated. It cannot quietly enter the good batch. With this process upgrade, porosity-related risk is reduced from 30% in 2025 to 5% in 2026, while production yield improves from 70% to 95%. So we're not only saying we control porosity, we are building a system that can monitor, stop, separate, and trace the risk. This is the Corona 2026 upgrade. From defect detections to process control. After casting, precision continues with Sunrise Machino CNC precision machining. For key medical precision parts, machining accuracy depends on fixture, positioning, tool accuracy, thermal stability, inspection feedback, and SPC trends. Our CNC process works together with the tight segment measurement. The goal is not only to inspect the final part, the goal is to use measurement data to keep the process inside a stable window. For selected critical features, we control machining tolerance down to plus minus 0.003 millimeters. When a dimension starts to drift, we want to see it earlier and correct it before it becomes a quality problem. Then comes Sunrise Medical Coat. Medical grade surface treatment. For Corona applications, the surface must support cleaning, handling, friction, and long-term use. Our validation targets include 4B coating adhesions and 2H surface hardness, together with age coverage and cleaning resistance. These targets help us confirm that the surface's treatment can stay stable on the edges, corners, machined areas, and complex structures. So Corona is a complete chain. Sunrise Vacuum Cast 2026, Sunrise Machino CNC, size measurement, Sunrise Medical Coat, inspections, and traceabilities. For medical and precision parts, quality means every hidden details must be controlled. Now let's move from hospitals to the ocean. The sea is one of the hardest places for any product. Salt, humidity, temperature change, water pressure, and long-term corrosions attack the part every day. In this environment, a small pore, a weak coating edge, or a poor material choice can become a serious failure. This is why Sunrise-Aqua exists. Sunrise-Aqua is our process package for marine and harsh environment components. It focuses on internal density, material stability, corrosion resistance, sealing performance and surface protections. For 2026, Aqua has 3 key upgrades: Sunrise-Clara cast, Sunrise aluminosilicon alloy, and Sunrise marine coat. The first upgrade is Sunrise-Clara cast 2026 semi-solid die casting technology. The process has 3 core steps: semi-solid die casting equipment, making slurry and mold filling, and injections. Semi-solid casting is not only about injections. The most important point is slurry quality. We control slurry temperatures, solidification, frictions, stirring time, sealing time, holding time, transfer time, and slurry uniformity. In simple words, we are controlling the state of the metal before it enters the mold. With better slurry control, we can improve internal structure density by 30%, reduce porosity down to 0.5%, and support up to 2 times sealing performance in target applications. Then comes Sunrise aluminosilicon alloys 2026, high corrosion resistance material. For marine parts, corrosion resistance is not only about the alloy length. It depends on composition control, melt cleanliness, microstructure, and internal defects. With aluminosilicon alloy 2026, we focus on controlling sensitive elements, reducing inclusions and oxide films, and improving material stabilities. Our target is to improve corrosion resistance by 30% under the same validation conditions. Finally, we protect the outside with Sunrise Marine Coat 2026 Marine Protection Coating. Marine coating is not simply paint on the surface. It is protection system. Pre-treatment must remove oil, oxide layers, release agent residue, and unstable material, surface material. The coating must protect flat surfaces, edges, holes, corners, and machined areas. For selected marine applications, our target coating thickness is 120 micron with 1,000 hours salt spray test validations. So Aqua 2026 not one single technology, that it is an update from internal metal structures to corrosion resistance material to marine surface protections. In the ocean, almost good is not good enough. Now let's talk about the robots. The robots are moving out of clean labs and into real working environment. For the robots, 3 problems decide performance: weight, precision, and fatigue. Sunrise-Robo is our process package for advanced robotic components. It focuses on lightweight structures, motion accuracy, and fatigue resistance. For 2026, Robo has 3 key upgrades: Sunrise hollow structures, Sunrise Machino CNC, and Sunrise Quiz Cast. The first upgrade is Sunrise hollow structure 2026 lightweight design. Lightweight design is not simply making the wall thinner. If we only make the parts thin, it may bend, crack, deform, or become unstable during machining. The real idea is optimized material distributions. We move material away from places that do not need it and keep material in the places that carry force. With hollow structures, ribs, smooth radii, and local reinforcement, hollow structure can reduce structure weight by 20% in target applications while keeping the part stable. Then comes Sunrise Machino CNC and Sunrise Test Ultra Metrology 2026. Ultimate precisions. For the ball joints, bearing seats, and positioning holes, a small error can become a large movement error. This is why machining and measurement must work together. With CNC machining, tight segment program, SPC trends, and closed loop compensations, we use measurement results to correct machining before dimension move out of range. For selected product side, critical features under controlled conditions, we target product precision below 5 micron. Finally, we improve long-term strength with Sunrise Squeeze Cast 2026 squeeze die casting technology. Squeeze casting is not only simply adding pressure, it is controlling when to press, how much pressure to apply, how long to hold it, and whether displacement is stable. This helps reduce shrinkage and looseness in thick area, making load-bearing zones more compact. In target applications, squeeze casting can improve fatigue resistance by 35%. This is Robo 2026, 20% lower structures weight, product precision below 5 micron, and 35% higher fatigue resistance. A robot can only be smart if its body can keep up with its brain. Now, let's look at commercial vehicle applications. A commercial vehicle part has a very different life. It must carry load for a long time, and it faces vibrations, thermal cycles, corrosions, sealing pressures, and upsell risk. For these customers, the question is not only can this part be made, the real question is, can this part survive long-term operations in large-scale productions? This is why we built Sunrise CommercialDrive 2026. Sunrise CommercialDrive is our process package for commercial vehicle components. It can support housings, brackets, pump bodies, motor-related components, thermal management parts, and structural aluminum parts. For 2026, CommercialDrive is supported by 3 production upgrades: die casting machines, CNC machining centers, and measurement equipment. First, die casting machines. Our new 1,600 tons leaking die casting machine expands our capacity for larger aluminum structure components. Our new 500 tons UBE die casting machine supports more stable production for medium-sized precision castings. These 2 machines help Sunrise cover a wide range of commercial vehicle components, from larger structural parts to more precise functional housings. Second, CNC machining centers. We added 2 new broader CNC machining centers to increase machining flexibility for post-casting critical features. For commercial vehicle parts, casting is not only the first steps. Bearing seats, mounting holes, sealing surfaces, and assembly interfaces often need stable CNC machining after casting. The new broader machines help us improve machining capacity, response speed, and process stability. So, measurement equipment. We use 3 cow-type cement measurement centers to close the loop between machining, measurement, and process corrections. Measurement is not only for final inspections, it helps us see dimensional drift earlier and correct the process before the problem moves into production. Inside the commercial drive, we focus on 2 directions. The first is Sunrise Duty Call 2026, Heavy Duty Structure Reliability. Duty Call focuses on heavy duty applications, strength, load path, internal density, key dimensions, and batch consistency. The second is Sunrise Fleet Proof 2026, Verified Mass Production Quality. Fleet Proof focuses on lower field risk by controlling porosity, shrinkage, leakage, corrosions, and dimensional drift before shipment. So, commercial drive is not only about more equipment, it is about connecting castings, machinings, measurement, inspections, SPC control, and fallback traceability into one production system. That is what large-scale manufacturing needs, not only capacity, but controlled capacity. So far, we have talked about casting, machining, inspection, surface finishing, and traceability. But many die casting problems start earlier. They start in drawing in the 3D modules before the first mold is built. This is why this year we also want to bring our manufacturing experience closer to the design stage. And now, one more thing, CASTA.
Hi everyone, I'm Kevin. Today we have shown many improvements at Sunrise, from casting and machining to inspiration and surface finishing. But all of this happens after the design is ready. For die casting, many problems start earlier. They start in drawing and in the 3D model. So before we make the mold, we need to ask a few simple questions. Is the material suitable? Is the design easy to cast? Are there any DFM risks? What's the rough cost direction? If we answer this question too late, changes become difficult. A CAD change is simple. A more change is not. That is why we built CASTA. CASTA stands for Casting Accelerated Simulation Tooling API. It's an online platform for early-stage die casting decisions. It helps engineers and sourcing teams check material, DFM, cost, and design knowledge before the project goes too far. It does not replace engineers. It supports better early decisions. Let me show you how it works. When you open CASTA, you can see the main tools: material selection, DFM analysis, cost estimation, video tutorials, knowledge center, and design guide. The workflow is direct. First, understand the material, then check the design, then look at the cost direction. If users need more background, they can use guides and tutorials. The goal is simple: make risks easier to see earlier. In die casting, Early is important when the design is still flexible. A small change can save a lot of time later. Let's start with material selection. Material is one of the first decisions in a die casting project. It affects performance, machining, surface finishing, and cost. In CASTA, users can look up common die casting materials and filter them by key properties. For example, they can check tension strength, thermal conductivity, or elongation. The goal is not to choose the final material in one click. The goal is to build a better shortlist and start the decision with clear data. Users can also compare two materials side by side. This helps the team see trade-offs quickly. One material may have better strength, another may be easier to cast or more cost-friendly. CASTA makes this comparison easier to read and easier to discuss. After material, the next question is DFM. Can this design be cast well? DFM means design for manufacturing. In die casting, DFM should happen before touring. Many casting risks are connected to the part design. For example, a wall may be too thick, a rib may be too deep, or the draft angle may not be enough. This issue may look small in CAD, but after touring starts, they can be expensive to fix. In CASTA, users can upload a 3D model and run an early DFM check when the analysis is complete. CASTA generates a clear report, but the result is not only test. CASTA can also show the 3D model with risk areas marked on the part. This makes the problems easier to understand. Instead of only reading a warning, users can see where the issue is. Each issue can be reviewed with more detail. What's the problem? What does it matter? What can be improved? This turns DFM from a simple warning into a real design conversation. At this stage, the design can still change. The war has not started, and the team still has options. Another useful part is AI Assistant. After the DFM report is generated, users can ask follow-up questions. For example, why is this area risky? How should I improve this rib? What should I check before RFQ? The assistant explains the result in simpler language. It does not replace an experienced engineer, but it helps users understand the first level of risk faster. This is useful for early reviews and RFQ preparation. If a deeper review is needed, users can download the full report. If the project needs more accurate engineering support, users can contact the Sunrise team through the platform. So the flow is simple. Upload the model, check the risk, view the 3D issue locations, ask follow-up questions, then decide whether deeper engineering support is needed. This is how CASTA moves DFM earlier, where it has the most value. After material and DFM, the next question is cost. At an early stage, teams often do not need a final code, but they still need a rough direction. Is this part simple or expensive? How does quantity affect unit cost? How does material choice affect cost? The CASTA cost estimator is designed for this situation. Users can upload a 3D field or drawing. Then they enter basic information such as material, quantity, and gravity count. CASTA gives a preliminary cost direction. This is not a final quotation. A final quotation still needs detailed review, including tolerances, surface treatment, touring, and production planning, but an early estimate is useful. It helps the team see cost structure before the project goes too far. The idea is simple: estimate early, quote later. CASTA also includes support resources. Video tutorials show how to use the tools. The Knowledge Center explains practical die casting topics. The design guide gives reference for common design questions. These sections are important because die casting still needs engineering. The platform can organize information and show risks, but engineers still make final decisions. CASTA helps bring manufacturing knowledge closer to the design stage. So this is CASTA, an online platform for early-stage die casting engineering. It brings together material section, DFM analysis, cost estimation, design guides, knowledge, and tutorials. This purpose is clear: help teams make better decisions before production begins, before the mold, before the first shot, before changes become expensive. The best way to solve a manufacturing problem is not always to fix it later, is to see it earlier. CASTA supports that idea. It brings Sunrise die casting experience closer to the beginning of every project. That is CASTA. Now, let's hand it back.
So, what is DCTC 2026 really about? It is about upgrading from experience to data, from inspection to prevention, from one good sample to repeatable productions, from hidden risk to visible process. Clara shows processes control for precision medical parts. Aqua shows stronger marine parts from internal structure to surface protection. Robo shows lighter, more precise, and more fatigue-resistant parts for advanced robots. CommercialDrive show how the aluminum die casting can support large-scale production with stronger capacity, better process control, and lower long-term risk. And CASTA show where the future begins, not at the press machine, but at the design stage. At Sunrise Metal, we are building a more controlled, more visible, and more reliable way to manufacture. That is DCTC 2026. Thank you. Let's build the future together.